Hello all, welcome to the next video on TCP. In the last video, we saw where transport layer sits in the OSI or TCP layer suite, TCP IP layer suite, and why did transport layer came into existence, and why as network engineers we need to understand transport layer. Also, we saw the header format of a TCP protocol, its header fields, and we also saw the concept of buffer, how buffer is uh, important in storing the information, and buffer in other words is also called as the window size or window in simple terms, right? So in this video we will understand the working of segments and how segments treat each byte as one information and tag it with a sequence number, and for each of these sequence number there is an acknowledgement number that is sent. So we will understand all this in today's video. So we know that the TCP data transfer in between the client and the server, or we call it as sender and receiver. So in the TCP jargon, we call the sender as a client and the receiver as the server. Okay. So in TCP, a segment is a collection of bytes. Okay. And each of these bytes has some kind of sequence numbers, and how these sequence numbers are given to it, we will understand now. So let's imagine that there is some kind of information being sent from the client to the server. Okay, so let us imagine that a message that is, hi, how are you? This message is being sent from the client to the server. Now, each of these boxes that you see here, you can imagine them as one single byte. Okay, so until and unless this one segment, okay, this segment has 1 2 3 4 5 6 7 8 9 10 11, so this has 11 bytes. So this is a very hypothetical situation here, but let us assume that this segment has only 11 bytes, and until and unless all these 11 bytes are full, this segment will not be sent from the client to the server. So it is important for the segments to be full, and then only the client can initiate a data transfer from itself to the server. So a sender will tag or will provide a sequence number to each of these bytes, right? So one byte has one sequence number. Okay, so for example, let us assume that this particular message, hi, how are you, and each of these letters are single bytes, and these contain a sequence number to them. So let us imagine that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. These are the sequence number of each of these bytes. So when the client is sending this particular data to the server, it will send them with the sequence number, saying that, let's say that it sends the first data, that is H, right? So let's imagine that it sent the data H, right? The data H, and said that the sequence number to this is 1. Okay, and it is continuously sending these messages. So the next message is I, whose sequence number is 2. The next is H, whose sequence number is 3. And these are being received by the server. So now Let us imagine that for some reason this particular sequence number 2 or the message number 2 gets dropped or did not reach the server. So the server will know that it has not received the sequence number 2 or the message number 2 in this whole sequence, and hence it can request the server, right? It can request the server that it has not received the sequence number 2, and the client can send the sequence number 2 or the message the message I with the sequence number 2 again, so that all these messages, hi, how are you, is completely received by the server. So this is just in a very layman term, this is how sequence number works, and this is how a sender and a client, sender client and the receiver or the server, they talk to each other and they find out which information is missing. This is in a very layman term. We will go a much more deep into it further. Now, for for every sequence number that the server has received, it will send an acknowledgement. Okay, remember that the sequence number is always given to a data or a byte. Okay, so here let's imagine that the first message that is sent from the server to the from the client to the server is H, right? So let's say that the data here is H with the sequence number as 1, which is sent from the sender to the client. Sorry, which is sent from the client to the server. Okay, let me remove sender and receiver from here so that it does not confuse me further, right? So the data is H and the sequence number is 1. Okay, now what the server is supposed to do is that the work of the server is to acknowledge each data or each byte that it has received. It has to acknowledge it to the client. So here what the server does is that it will acknowledge, right? It will say an acknowledgement, it will send an acknowledgement to each of these sequence or bytes of data that it has received. So it means that it has acknowledged, and the acknowledgement is always the number adding the sequence number. So here the acknowledgement would be the sequence number plus 1, which means it is 2, and it will say that yes, I have received your data whose value is H and whose sequence number is 1 that I have received. Now the acknowledgement also plays an important role in telling the client that the next sequence number that it is supposed to send from its side is the data whose sequence number is 2. So here the acknowledgement is 2. It is telling the client that the next sequence number that it is supposed to send, or the next sequence number the server is supposed to receive from the client, should be number 2. So the next data that the client send is data equals to I with the sequence number as 2, right? Now what the server does, server again acknowledges it with a number, acknowledgement number, which is 2 plus 1, which is 3, and saying that yes, I have received your data, which is I. Now this 3 again is an acknowledgement, right? And it is also denoting, or it is also telling the client to send the next data whose sequence is number 3, which is the data with H. So this is how sequence and acknowledgement number are exchanged between a client and a server.